I'm Anil Kumar, and in this video, we'll learn different techniques to model a given situation. Now, we have taken up a situation where we have introduced 100 finches in the city of Toronto, and after 10 years, we know that their number reaches 1,000. So, that is what we know. We need to model this situation and then calculate their number after 20 years. So, that is the question. So, we have a situation where there are 50 finches. These are beautiful songbirds which are introduced in the city of Toronto. After 10 years, their number reaches 1,000. We need to model this situation and figure out their number after 20 years, right? Now, to model this, we'll actually use three different ways of modeling it. Since we could assume this situation could be linear, right? So that could be one model. We could assume that this is exponential growth of these finches, right? So that could be another model. And we will take a realistic approach also, which we call logistic model, right? So we'll approach with logistic model also. So we'll actually try to understand these three models while working out the number of finches after 20 years, right? Linear model is kind of straightforward. Let us assume that the growth rate is linear. So that is to say you introduce 100 finches and they just go linearly up, right? So here we know one thing, that let's say this is t time, and that is the number of finches with time. So introduction of 100, and after 10 years, let's say that's the point, after 10 years we have 1,000 of these. So that is the model. To write down the equation, we need at t equals to 0 we have 100. So at t equals to 0, n of t is 100. We could write n0. Let me write this time n of 10. After 10 years the number of finches is 1,000, right? So we have 2 points. Using these 2 points we can find equation of line. Let's find the slope first, m, which is 1000 minus 100 divided by 10 minus 0, and that gives us 90, right? So 900 divided by 10. So that is the slope for us, and since at 0 the number is 100, so we get the equation which is n of t is equals to slope of 90 gives us 90t plus initial value of 100, right? To find the numbers after 20 years with this model, it will be n of 20 equals to 90 times 20 plus 100. At this stage we can always use calculator. 90 times 20 plus 100 equals to 1900. So less than 2000 will be the number of finches after 20 years. So that is a number in 20 years, right? So with this linear model, we kind of get around 2000 finches in 20 years. Now let us consider the next model, which is exponential in nature. So here initially the growth rate will be lesser, slow. So initially in exponential models it is slow, and then it rapidly increases, kind of like this. In linear model the growth rate is constant, and you saw that was 90 per year, right? So in 10 years it will be times 10, right? So that is how we got our number. Okay, now in exponential we have the same situation in a way, starting point at 100, and then we do have a point here after 10 years. The number was really 1000, right? So with that information you can actually also model the situation in exponential form. So in this case you can write the equation as number of finches with time will be initial number of 100 times the growth rate to the power of t. Now to find the growth rate we can use the point here, which is after 10 years there were 1000. So let's put 10 here and 1000 here. So we get 1000 here equals to 100 b to the power of 10. So when you divide 1000 by 100 you get 10 equals to b to the power of 10, and from here you can say b equals to 10 10th root, right? So let me find 10th root of 10. So that is interesting. 10th root of 10. Okay, so 10 to the power of, you could also say 1 divided by 10. Okay, that is the 10th root. And this number is 1.2589. So we get 1.2589 is the value of b. So we'll use this value to find number after 20 years. Let me first write down the formula. N of t is equals to 100. B is 1.2589 to the power of t. So this is the exponential model for the same situation, right? Let us calculate what the number will be after 20 years. So we'll replace t by 20 in this case, correct? 1.2589 to the power of 20. So let's calculate. Since I have the number there, I will just say exponent 20. Calculate this value, right? Okay, equals to, and then multiply this by 100, right? Times 100. So that gives you 10,000. Wow. So we get 10,000. Oh my God. So after 20 years, if you go with exponential model, you get 10,000 birds in your city, right? So that will lead to noise pollution, apart from the beauty of their colors. Okay. So realistically, the city cannot afford to have so many, and of course in a city, those many cannot even thrive. Therefore, we go for a logistic model. Logistic model says that what maximum can the city take, right? So that is the whole idea. So we have to assume that number. So looking into the other birds population, let us say that the maximum capacity here is, so we say max capacity is how much? That is the logistic. So we say let the max capacity be 5,000. So we have added a criteria here to our model that it cannot really grow like that, right? There are realistic restrictions, right, or limitations. So we expect that they will go fast, but then they will taper down to a maximum value of 5,000. So that's the whole idea. I hope you appreciate that. So this means it will approach 5,000. So that is called our logistic model, and this value is 5,000. Okay. Starting again with 100, right, and taking the same point at 10, we have 1,000 number here. So all of the situations are same, right? Now see how different models give you different numbers, and that is kind of important. Now this model is written as n of t equals to carrying capacity c, right? Carrying capacity c, 1 plus a, and is exponential b to the power of t. So that is what it is. Now we can find all parameters of this model by the known situations. First one is when n is 0, so starting value is 0. At that time, capacity we know is 5,000 to begin with. The city cannot take more than that. 1 plus a, b to the power of 0. Now anything to the power of 0 is 1. So we are left with 5,000 divided by 1 plus a on the right side. And initially starting value is 100. So we have 100 here, right? So we can cross multiply. We get 1 plus a equals to 5,000 divided by 100. That is 50. You can solve for a now. So a equals to 50 minus 1, that is 49. So we get the value of a. Now let's continue on this side. Since a is 49, in this formula, we can write this formula as n of t equals to capacity of 5,000, okay, divided by 1 plus a is 49, so I'm writing 49, and b to the power of t. We need to find b now, the second variable. That we can find from the given value, that after 10 years we have 1,000 finches, correct? So let's put this. So 1,000 after 10 years, so 5,000 here, 1 plus 49, b to the power of 10. So after 10 years. Now when you cross multiply, you get 1 plus 49, b to the power of 10 equals to 5,000 divided by 1,000, correct? That is number 5. Now we can say 49 b to the power of 10 equals to 5 minus 1, which is 4. So b to the power of 10 equals to 4 over 49, and b is equals to 10th power, right? So 4 over 49 to the power of 1 over 10. So that is what the value of b is. Let's calculate. So we have within brackets 4 divided by 49, bracket close, to the power within brackets, let me write 1 divided by 10, bracket close. That was not required. Okay, equals to. So we get 0.77. Okay, so we get 0.7783. So that's the value of B. Now that gives us our ultimate formula of logistic model. So let me write down this formula here now. So we have n of t equals to nt equals to 5000, okay, divided by 1 plus 49 within brackets 0.7783 to the power of t. Do you get the idea? So that is how you get your formula, right? Now since you know B, now the idea is to calculate what the number is going to be after 20 years. So let's calculate here. So n after 20 years will be equals to, let me push this page a bit to the right. I hope everything is visible now. So we have 5000 divided by 1 plus 49 and all this 0.7783 to the power of 20. So let's calculate using this calculator. I already have this number. So okay, we'll begin with the beginning. We'll say 5000. 5000 divided by within brackets 1 plus 49 within brackets 0.7783 within brackets, power is 20. Okay, and then we close the brackets for the denominator, equals to. So we get a number which is 3770. Okay, so after 20 years the number of inches will be 3770 with this model. Do you understand? So if we go with our model, then the numbers which we are getting are kind of like this. With this model, after 20 years, that means somewhere here, after 20 years the number is 3770. Here in this case, after 20 years we get 10,000. Do you see that? And here after 20 years you get 1900. So these are different results from different models. You have to think about which model to use in which situation, right? As you can clearly see here, this is constant growth rate. Exponential means it slowly moves initially, then it rapidly increases and then keeps on going at that more and more rapid rate, right? Therefore the number is so high. In this case, it is slow to begin with, picks up and then slows down, tapers to the maximum value, correct? So that is our logistic model. Many times we apply that to natural situations as we have done here. So that is how it is. I hope with this your concept about modeling is better. You can subscribe to my videos. I am Anil Kumar and learn a lot. Thank you and all the best.